we're going to get going.
Okay, so hey guys, we're back. This is our second show of the Think Tank. Like I mentioned before, we'll be covering some of the human-computer interface techniques and theory, which will also include covering some information on DARPA and MIT. But I think first we're going to discuss what's breaking in the news right now, which is POTUS coming down with COVID. And so with that, tonight with me is TMC, Breaking Spectre, Tennessee Homesteader, and Drunk Pinata. And then I'll just like we always do, let the conversation kind of take off. And first, I think we'll talk about POTUS and COVID. Does that sound good?
Yep, it's current.
Like a plan.
All right. So we were just starting to get into it before I hit record. And so now we can kind of carry on with that conversation. What were you guys saying about your theories on why he's got COVID?
So Pinata was sharing some information that he had read, I believe it was on the board somewhere, and they were indicating that to some extent the announcement of POTUS's COVID issues and FLOTUS for that matter were accelerated. The timeline was accelerated, and the assumption out of the posts or the threads that Pinata was reading was that the original goal was to have this happen more closely in alignment with the election to, I guess, inject more confusion or smoke, if you will, into this whole conflict that is the polarization that we're seeing. And the election at this point is really the centerpiece of all of that, just because that's what's upcoming. And
right,
so,
and this was just something I had just seen right as we were having our conversation. I just happened to start having access to the internet again. I was out for a few hours, and so I was just coming back, and I was just perusing through some of the different theories. I thought it was interesting as far as timing is concerned, but as far as like practicality and like how ethically, I didn't feel right. But it was just interesting to consider. And in this, time of a lot of this fog, it's always good to consider like a lot of options so that you can kind of suss out which ones are the most plausible, which ones are the most likely, given, like I said, kind of like an ethical point of view, because I really doubt that they would kind of do that from that standpoint. Like purposely, like I think they would try to avoid that at all costs, like we were talking about just before we went back into recording here. So, it was just interesting, but that's kind of where we were going before, like, and we were just talking about why now, like who might've been responsible, things like that. So that's kind of the origin of kind of where we got to this point where we are musing from this point forward. So beyond that, is there any other theories as far as like, do we think that, Tian, we were talking earlier about is it a few days ago or a week ago? The time just kind of gets away from me at this point. The photo from Air Force One, I sent you a DM where we think that they've nailed down that date to 9/18.
Yes, it was 9/18.
So this was on Air Force One because POTUS is on it, but
correct.
It was the smaller planes because of the airport that they went to the rally at.
Correct. That was the rally in that Bemidji, Minnesota. I don't know how to. I know it's pronounced a certain way, but I don't know how to do it. That's where that rally was on that day. And interestingly enough, how I've been tracking the names of the cities where the rally is in the state. And that one was pretty interesting because that's another 1314 Pinata, another Minnesota, right? And for those of you who follow, 1314 ties to the Justice Q drop 1314. So I found that pretty interesting. And indeed, so
to clarify it a little bit further, the Q1314 is the Justice Cannon, where it says we have some stringers where it says on ready. Correct. And the stage set, basically.
Correct. The in essence, the string of placeholder yes kind of thing. They end up with a lowercase y. But yeah, that's exactly that. And that's the one that opened up the what was the third private board from Q, that only Q can post on that. And he doesn't do that often, but when he does, it's significant because there's no
Patriots fight.
Right, the Patriots fight. Nobody can post to that. You can reference it, but you can't post it in there. So I find that as a significant thing. Then, of course, that's when Scavino put it out there. And then, as we saw a few days later, Q uses that exact same photo, which happens to also be the day that, as you can see by the TV, that's the day that RBG passed. So there is a significance to that, because when you look at now, again, how it ties into POTUS, if we look at it right now, we're on 10/2 today. 10/1 was when POTUS was tested, right? That's 13 days, 14 days to today. POTUS's announcement tweet was at 54 minutes after the hour today. That's the incubation period. Yet you have the media going bonkers about the debate. You had Chris Wallace peeing on himself, practically talking about the masks and the lack of masks, and how POTUS didn't wear masks, and how the First Family didn't wear a mask. They came in wearing a mask, but then refused to wear the mask while they were sitting down. That was a violation of the rule, blah, 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 blah. And yet they totally ignore that you cannot catch it and test positive overnight.
Whoops.
Oops. And let alone that POTUS tweets about him having it, and then 2 hours earlier he tweets about Hope Hicks, who has not been seen other than a Fox article a while back when she came back into the sphere of the Trump arena, and yet she's pictured on this photo on Air Force One.
Yeah.
No, nothing to see here, folks. And media, no, let's not do any investigative reporting at all.
So I guess there's two things that I guess come to mind. Number one, and we briefly talked about this before we started recording, is does POTUS indeed have been tested positive for the SARS-CoV-2, or is this the political COVID? Based on the article, for folks that are following along here on today's broadcast, I covered an article that got into that very scenario about the belief that there are two COVIDs in play here. You have the disease, virus form that, people can actually acquire, versus the politically convenient COVID to use for the purposes of carrying forward the Davos elite type crowd's plan for exercising the New World Order, the control mechanisms that we see for the social distancing, for the mask wearing, et cetera, et cetera. And then I guess the second part of that is the timing of it all. What is the significance of the timing, especially now? And I know you guys are just touching upon some dates, but squaring that against us now being 32 days away from election, the incubation period, Homesteader, you just cited, obviously, as he is now tested positive, he's going to be quarantined. They now, at this point, have him at Walter Reed, late development here this afternoon, that he's going to be stationed there, and chances are he'll have to be quarantined for, I would imagine, 14 days, right? Mm-hmm. So where does this all go? Is it legit? Is it strategy? Is it a tactic? And did he potentially even beat Joe Biden to the punch and using it?
That's on the second part of that. That, I think, from that perspective, brilliant, because what ends up happening up to the debate, right? I for one was saying, watch, within 2 weeks of the debate, Biden's going to claim being exposed to COVID.
And I think we all thought that, right?
Right. Some significant prevention from him joining the debate, and the COVID was the most logical, right? Exactly. So that has come and gone. He showed up. He was able to stand up and not fall flat on his face for an hour and a half, physically, I mean, and the story, right? I mean, we all know what happened with the debate and all that kind of stuff, not get into that. But from the COVID perspective, all of a sudden POTUS comes out tested as test positive. Now Biden can't use that.
Mm-hmm.
And not only that, think about the chest thumping that the Democrats are doing. Biden wins. Biden was brilliant. Biden withstood the onslaught of nasty Trump, blah, 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 blah. And now they're riding high and, look, for all the things that he now has COVID, ha, 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 ha. And then what? Cut him off at the knees?
Yeah. How many of you guys actually saw the CNN stuff that was coming out shortly after the announcement last night, where you would have thought between Brian Stelter and Lemonhead that the sky was falling, the world was ending, we're going to have to swear in Pence right away, and, doomsday scenario.
Right. All this while after Cuomo, whenever he was, tested positive for COVID, they was allowed to broadcast from his basement. There was no call for, his deathbed. Remember, he was busted out by that guy on the bicycle at his new build.
You mean Chris, right?
Yeah. Sorry, I said the other one. Yeah, Cuomo.
Fredo. Yeah, absolutely. And so, look at it. And then what does POTUS do before he goes to Walter Reed, right? He cuts a video. He looks perfect. He's not sweating. He's not like holding up like I got COVID. He says, hey, I feel good. FLOTUS is doing good. We're just doing this for precaution. I'm off to Walter Reed. See you guys in a bit.
So basically it thwarts somebody like Maggie Haberman's tweet that said last night he looked lethargic.
Exactly.
Well, you brought up a good point before about him taking hydroxychloroquine earlier.
That's correct. I don't know if you guys recall here, early days of this quote unquote scamdemic. HCQ obviously was a big portion of that. Right to try. Q has told us, hey, we should have a right to try. We shouldn't have just vaccines rammed down our throat, whether it be Moderna, Remdesivir, whatever Fauci's tied into and funded and looks to benefit from. But HCQ, which the media is vilified. And if you remember right, and I tried to and find an article by headline, couldn't find it in my trove of stuff, but nonetheless, I do recall at some point that POTUS was on a protocol using hydroxychloroquine, and whether or not he used azithromycin and zinc and everything else along with that, I don't remember, but I think a number of folks remember that as well.
Yep. Oh yeah, he even said it on a video. Correct.
Mm-hmm. At least I seem to recall it. The question is okay, if he has indeed had a regimen, whether it be back then or is he still on it, I don't know. How does one contract the virus having already been through that regimen? Is that possible even?
Right, that I don't know. But because the doctor, what's her name? The one that's the most loud advocate of it. The one that caught all kinds of flack. Not the one that was fired, not Dr. Gold, the other doctor. Anyways, the one that said that she had 92 patients and she prescribed that, right? She tweeted and his almost like a hysterical tweet and said, "How dare they take him off, HCQS and all of that." I don't know because I've never heard. Does it have a cumulative effect in the sense that there's a certain point that you build up a resistance that the virus cannot come, or it can only happen while you're on it?
Do you develop the antibodies, or is there some level of herd immunity that you would naturally develop having used it?
The latter. From what I heard, and remember when they did that presser in front of the Supreme Court building, that there was a little Q&A type of thing afterwards out there on the street. And one of the doctors was basically saying that gives you the time to be able to have the development of the antibodies. In essence, it blocks the severity of the virus from it because the HCQS concentrates on your lungs. That's why the overdose, it kills people when you overdose it, because you don't overdose it by the blood content. You have to test the concentration of it in your pulmonary system, and then on top of that, you use the zinc to allow your body to absorb it better and to resist, right, etc. And the antibodies don't even come. The antibiotics don't even come in unless you're diagnosed with it and you're under treatment. The others are prophylactic.
Right. And of course,
Go ahead. Sorry.
Go ahead, Bracken.
The thing I was going to say, of course, when talking about hydroxychloroquine, the sole benefit comes to play if you're diagnosed early its use. Obviously, for those that may be listening to this who may still have doubts about the misinformation, the disinformation, the propaganda being spewed by the Mockingbird media on this, they've cherry-picked the data, referenced various tests and studies in that where they gave it to them way late in diagnosis. They also did not couple that with azithromycin and or zinc in those particular studies. And so I think the last count that I remember seeing by way of articles is that there have now been over 52, 56, something like that studies, and only 9 of which have shown potentially any negative effects, if I recall correctly.
Something like that I recall as well. Yeah. The ratio of good to positive results to negative or complicated results, way far away. The positives far away.
I think it's just, we're just going to kind of have to sit back and wait and see and how this card is played. We know what the media is doing, and I think we've kind of hit on this. What you guys think about it. I do. I'm interested though to try to get to the main course, which was tonight about the human computer interface. So if y'all are ready, unless y'all have anything else to add to that, I would love to get to there if we can. If y'all ready, unless y'all have anything else to add something. Okay.
We just want to wrap up the current events.
Yeah. Mm-hmm.
Yeah, I think that pretty well brings us current where things are at the moment, at least.
And not to like bring this full circle, but the last episode we brought in the dishwasher conversation. I was again at my kitchen and I accidentally knocked my phone into the kitchen sink with the water full, which is what you're listening to me on now. So hopefully it's coming through okay, and it's not garbage.
No, you
right?
sound good, but you need to stay out of the kitchen if you're going to come into this show. I'm just going to say.
But I have to say, I'm surprised that the phone is still working. Fortunately, I had the headphone jack plugged in, so I think that's what saved me. So
yeah,
right to move on.
Pinata, out of the kitchen, please.
I think the Q posts wash the water kind of come to mind.
Yeah, exactly.
Yeah. Apparently I need to do that. That's just sound advice.
I have a similar story, if I may. I'm on business and I'm in St. Louis, and I step out of the cab to get into the building. It's pouring. There's like 4 or 5 inches of water running down the curb, right, deep. And I take one step and I hear this. You look down. There's my phone. It's 6 inches of water.
Yeah, y'all can stay away from the
water, man. Oh.
If you could stay away from the water, that would be great with your cell phones.
Yeah.
TMC, did you want to go ahead and bring up I know you brought a couple things you wanted to share tonight when we start.
Yeah, I wanted to comment on the COVID thing. Looking beyond just what is today. When we look at this push for vaccination and for permanent social change as it relates to social distancing and wearing masks, etc. When this is all done, he's going to have antibodies. He's going to have an immunity to it should he survive, right? Likelihood of survival probably very good. And this is going to be right on time for the Project Warp Speed and the rollout of that. And the media is going to try to pressure the president to take a vaccine in order to illustrate to the rest of the world that that is what is needed. And what I'm anticipating is a simple response to the effect of, why would I take a vaccination for something that I already have an immunity to? That being said, when these test strips that he announced sometime last week, like 200 million of these go, no-go style tests where it's a piece of paper, a piece of cardboard with some genetic information on it that's specific to coronavirus, that you swab the inside of your nose, 3 rotations one way, 3 rotations the other, and then you take that swab and you rotate it on one of the sides of the piece of cardboard. Keep in mind that you have placed some solution on the cardboard in order to activate the material that's in a dry form on the cardboard. So you take that swab that you've scraped your nose with, basically just inside the nostril, and then you put it on that card and you rotate it 3 times, and then you fold the card on itself after removing an adhesive strip, and you wait about 15 minutes and you get a positive result or a negative result. There's no machine required. It's a simple disposable cardboard Q-tip based test. That's it. That's the test.
But at the end says you're pregnant?
It's right. You're pregnant with the COVID, right?
Exactly.
Your cells will be bursting with COVID.
There's a little plus mark on it. Sorry.
3 lines. 3 lines is yes.
Like
2 lines
plus
is no.
and plus and plus.
Well,
Sorry,
here's the long game. It's cool, man. It's cool. Here's the long game for that. If they're going to try to, if corporations are going to try to roll out this mandatory testing to try to fear everybody into COVID, right, or into this idea of COVID being around and everybody's always testing positive, et cetera, and therefore we need a vaccine in order to reintegrate into society, whether or not you go back to school, you go back to work, you're eligible to go to the store and buy food, travel, whatever. The fact of the matter is once you test positive for COVID, even if we go through each individual going through a quarantine period of time, this mandatory tracker tracing type technology could theoretically be turned around, whereby you say, fine, I tested for COVID. I'm going to go away for my 14-day period. It doesn't matter if I test positive for COVID again, because at that point you're reading the antibodies, which have the genetic information that you're testing for in it anyway. And so why would I be required or mandated to take a vaccine when I've already been deemed by this testing procedure to have COVID? Therefore, naturally, I would have I'm still alive, so my body immunized itself to it. And so I have the antibody, so it wouldn't matter if I test positive for COVID ever again because I have the antibodies. So what you're testing for is going to test hot with the antibodies, in my opinion, as it would for the virus. It's looking for just that genetic information that's specific to coronavirus. Furthermore, in order to apply or deal with this idea that viruses mutate, you would need to have a generic enough genetic sequence in order to account for some amount of mutation with the COVID-19.
You're not speaking of the RNA vaccine by any chance, are you?
Well, that's part of it, right? What I'm getting at is this idea of preservation of choice. If you want the vaccine, even after you've been deemed having COVID, go for it. But it shouldn't be mandatory. And so what I'm getting at is this go, no-go test is going to have generic coronavirus code on it, software, RNA, DNA, whatever. The genetic code that's on this test material is going to be generic. It's not going to be a specific strain of COVID-19, knowing that it mutates. Otherwise, the tests are going to be ineffective after a day, a month, whatever.
So in essence, if you had the flu or you had the COVID, the previous versions of COVID, the pre-19 versions, right? You're going to test
any
positive.
Coronavirus, SARS, MERS,
exactly,
all of it, dude. So what it's going to do is it's going to provide the public with the ability to hear the narrative of, wait a minute, I'm still alive. People are still alive after having COVID. Right? So they would have antibodies. Why would there need to be a required vaccination if I'm immune? If I already have the antibodies, why should that be deemed necessary for me to return to work? And so what I think may happen is when he gets back and they go, okay, we're ready for the vaccine, this, that, and the other, and they're gonna straight up ask him, are you gonna take a vaccine? I'm guessing, and I'm hoping more so than anything else, that he turns around and says, to some extent, that's the dumbest question I've ever heard. Why would I take a vaccine for something that I've already been exposed to and have immunity for? There's no reason for me to take a vaccine because I've already had it and I'm still here. My body's immune.
I think you hit the nail right on the head, and it's precisely why you don't hear the Mockingbird media to say squat about what's happened in Sweden. Now,
Right.
those that have followed anything pertaining to COVID know or should know by now that Sweden took the approach of not doing a freaking thing.
Full herd.
And guess where they're at right now?
Near zero.
Precisely. And you know who else did that here stateside?
South Dakota.
Ding, ding, ding. There you go. So we have our case studies already built in.
Yep. Good for her too. I mean, she caught a lot of flack. And
you were about. I thought you were about to go there, TMC. When it first started going down, I thought that it would be interesting because you think of the flu season and the mortality rate that's there every year, and no one says a thing. And then this was coming along, and I'm like, wait a minute, are they just basically like using a generic version of that? I mean, I know it's not the same thing because now we know it's not the same thing, but it's similar, and that we figured out with some of the mortality rate.
It's a proprietary man-made version.
But the point is that if all they had to do was make it trackable and traceable, and once they did that, then it introduces a fear factor, and that fear factor is the whole point of the whole thing anyway.
Yeah.
But what I'm saying is that just the fact that you made something traceable and made it public was all they needed. So with these tests and the fact that they're going to basically looking for generic coronavirus, that's all they need. It's like a jumping point from something specific that they may have introduced, but in the same family. And then now they're just going to be, this is also that, but really it's not that. It's a version of it, like a very offshoot version of it.
So they've created a virus that they're able to then patent the solution for. And you can look up coronavirus patent, and there's patents all over the place for coronavirus and for inoculations for that. But on that note, dang it, I lost my thought. It doesn't matter. I totally lost my thought. It sucks. Hello.
Well, I guess to that end, how does this segue back toward the AI, the chip, and all that?
There's two prongs for that. There's the synthetic version, and then there's the genetic manipulation, genetic mutation version that is really where the future of all of this is going when you think about synthetic biotechnology and this idea of the RNA, mRNA type vaccines where they can.
Right.
Yeah. So
that's the one that scares me.
Yeah. Yeah.
And then you can add whatever floor you want to it.
Yeah.
Yeah, and COVID, if you remember right, is a little bit of an acronym. The code name Operation Virus Identification 2019. It's the ID 2020 stuff that's probably the most concerning. The type of crap that the Bill and Melinda Gates Foundation would love to make sure each and every person on the planet has is some biometric implantable dot that allows somebody to be scanned under infrared or black light or what have you to know whether or not you're allowed back in society to engage in commerce.
It's more. I think it's more sophisticated than that.
Simplifying, of course.
Sure. Well, that's the first stage. The second stage would be to administer some type of a barcoding scheme into your genetics so that you can be scanned with microwave, millimeter wave, or infrared or ultraviolet light, and they are able to resonate your DNA, and you get a standard yet unique resonance in your DNA. So the first step would be the quantum dot nano chip type crystals that would go into your skin that would deliver a quote unquote vaccine, but then also stay there and be bioluminescent, and it would illuminate and be read, can be communicated with, let's say, using some wavelength of infrared light, for example, or ultraviolet. But the next evolution of that is to insert genetic code along with quantum dots being one method to then self-assemble, modify your DNA and self-assemble and create unique markers in the body that can be remotely read. That's just the mark piece. The other part of this, when we talk about computer interfaces, would be to reprogram your biology, your cells, to ultimately express proteins that interface with wireless energy. And that can be electromagnetic, meaning an electromagnetic wave, an electric field, a magnetic field. It can also be light. It can also be sound, ultrasound, infrasound, whatever, or a combination of those things. And those are the two paths that we can go down today. I think we're going to start with, we're going to stay away from the genetic modification piece because it's a little more clearly defined with the synthetic, where we look at nanomagnetic particles and we look at helmets that are placed around the head that send and receive light, sound, and electromagnetic waves to interface with the brain. If we get that far, maybe we'll do another show. I don't know how long this is going to take, but then we can start looking at the different genetic sciences, things like optogenetics, chemogenetics, magnetogenetics, sonogenetics, mechanogenetics, electrogenetics, whereby institutions or academia are studying these genetic characteristics that exist in nature, isolating that genetic code, and then looking at putting it in things like mice and primates to be able to develop interfaces, computer interfaces that are literally grown in the body. But that might be too far out there for the first introduction to this. So what we'll do is we'll start with just this idea of a brain-computer interface, because this has been done and it's rough and brutish and archaic at this point. At least that's what they're telling us. They're telling us that you literally have to undergo surgery at this point and have some crazy disease like paralysis, epilepsy, or whatever in order to, in order to even need this. So don't worry, general public. This is just to help people that need our help, because we're loving, we're kind, and we're gentle, and we're loving, and it's all BS.
I guess TMC, as you get into this, can you shed a little light for the audience that may be listening to this? Which avenue does this really take? Because there's a couple schools of thought on this, right? You got the Elon Musk that's developing his own version of some sort of interface. And I believe Facebook / Zuckerberg are also developing a version of their own, right? Mm-hmm. But they're not necessarily one and the same.
There's many different, we can highlight all of those if you want, but there's many different people that are interested in this technology. Here's an article that highlights a few. And Facebook is another one. I've got that in the notes here. Regina Dugan gave a speech at Facebook that discussed using near infrared technology to be able to read and write into the brain. It's an entire video on it. And that's kind of, I think will be an intermediate demonstration, if you will, as we tie in the genetic piece, because the reality is for the near infrared interface to work effectively, the brain cells need to be modified. And there is an article that we'll cover that talks about introducing genetic code that's piggybacked on viruses to alter neurons to change some to be able to talk to it, and change others to be able to read from it. So you're creating an input and an output, and genetically modifying the cells in the brain to allow magnetic energy, light energy, electric energy, or sound waves to ultimately interface, both read and write, to the brain. We'll get there. But to your point, this would probably be a good one to look at, where it says Neuralink, Open Water, DARPA, N3. We'll go through the N3 program in detail. How far is the full immersive matrix style virtual reality? And it says these days virtual and augmented reality is a very hot topic. For example, one of the most valuable startups, Magic Leap, which aims to develop a glass-sized all-day wearable AR headset, which can be the successor of mobile phone technology one day, right? So what we understand is AR, you put a phone inside of a face mask kind of a thing, and you put your phone right in front of your face. So what they're getting at here is that they're turning into just their own dedicated versions of this. And so what you see here are sensors and cameras and microphones and all these things that are going to create an overlay for the visual and audio experience. So you get augmented reality. You see the world around you, but there's this overlay. And really where we're going is having this type of idea, virtual reality or augmented reality, pumped or ported right into your brain, where you don't need a wearable anymore. They will literally just stimulate the certain regions of your brain in the right combination and the right succession to create active, fully immersive hallucinations, up to and including being able to smell, taste, and have the sensation of touch, in addition to sight and sound. So you will have an active ongoing hallucination whereby all 5 senses, including your emotions, in addition to, I should say, your emotions, will be played like a harp as you move around through your day. And this will be the future of communication between people and things like watching what we would equate to watching TV or a movie today. Big tech companies, right, are seeing the potential in VR, Facebook, Oculus, Microsoft, HoloLens. And so this is this idea of augmented reality where you're looking at something and then it is able to create a digital overlay so you can break something down. So the easiest thing would be like, think of a car engine or something like that. And when you wear a device like this today, what they're saying is there's software that will be able to give you the exploded view. So you can look at a diagram, parts diagram, and you can see assembly instructions and have it overlay exactly what steps need to be done, exactly what parts are necessary. And it's no different really than looking at a YouTube video going play by play where, okay, I'm going to watch for 5 seconds and perform that function. I'm going to watch 5 more seconds and perform that function. They're just taking that a step further, and they're overlaying it where it's in front of your face 24/7 through a translucent or a transparent plastic or glass that then allows you to go through those functions that you would normally, follow along in a YouTube video for a do-it-yourself, but it's done more efficiently, so to speak, where it's over your face.
Some of that's already out there today.
It is.
Yeah. Because I remember seeing some of that for mechanics, basically robotics in particular.
Well, Space Command is using this all day long now, where they're managing. I saw articles where they're managing satellites this way, and they're working. They're module. I don't want to really call it modulating, but you can put modules on data sets or modules on algorithms or modules on whatever, and then you can start manipulating those things in a virtual 3-dimensional environment. That's a much more efficient graphical user interface than it is looking at a spreadsheet or a database and having to look at code and everything in 2-dimensional text. So they're taking complex data sets and they're putting them into a visual format that is a little more intuitive to the way that humans interact, which 70% of our information input is visual. So the point is we're already here. They're rolling this out like it's, hey, this is what's coming up. Well, no, the reality is that this stuff is here. It already exists. And if you don't think it does, just look at what's available for children for video gaming today, and it's pushing this whole idea of putting a phone right in your face and having that be your gaming system.
Your VR right in your face, right?
Mm-hmm.
Oh, I have one.
That's consumer grade.
Yeah, exactly.
I have one. I mean, I have an Oculus right here that takes my smartphone and basically turns it into VR. And I've had it for 4 years, and it's amazing. And it's an old one. It's one of the first versions.
And just look at the 3D, the VR technology that's gone just to the commercial, consumer version of it. Right. From the clunky old video arcade type stuff that you wore that was basically 8-bit, displays, to now where it's virtually, no pun intended, lifelike.
Yeah. I guess
that's just in my lifetime, less than half my lifetime.
I guess I might even throw this out there, since the debate and quote unquote how well Joe performed during said debate. There was a lot of speculation that he may have actually worn a contact lens that may have had a teleprompter built in.
Correct.
Yeah, I found some interesting. I found a patent that kind of matched up with what could be possible, where you put a wearable on your wrist, basically, and it is able to send and receive energy into your bloodstream that interacts with nanotech in your bloodstream to measure, analyze, and quantify lots of your physiological functions, and then also be able to modulate your physiology. So this idea of electromedicine, so that if you couldn't go get an injection every 30 minutes, they could potentially use electromedical procedures to modulate something that's circulating in his bloodstream for 6 or 8 hours. They give him an injection knowing that the body won't process it out immediately. It'll just flow through his bloodstream, and then put a wearable on him that's able to go in and modulate and manipulate that nanotech. If you don't believe me that that's possible, I swear to you it is. I mean, I can look it up and show you, but it's really not really in the scope of tonight's discussion. To your point, Breaking Spectre, yeah, they've got all kinds of cool stuff they could strap on that guy or inject into him and make him artificially function, for sure.
When you were talking about the previous article you have up there, which is the previous tech, it reminded me of, I know how they say it comes out in the movies earlier, right? Because they're kind of telling the movie Brainstorm, if you remember, with Natalie Wood, which happens to be her last movie. That was exactly that. They recorded through people's brain. Obviously, they recorded their entire physiology aspect of it, including their feelings, and they could play it back. You could play it back into your own brain.
Yeah.
And right. And the whole, I mean, they even had one scene where the guy cut a loop of having sex and an orgasm, right? And he almost had a heart attack because he was experiencing that over and over and over and over in the loop.
Yep. And that's where, when we look at some of the DARPA technologies, that's where they're going, where they are looking at encoding memory, manipulating memory, trying to understand how the brain functions. And that's why when you were saying that, I kind of cut over to this screen right here, the Brain Initiative. Yeah. This was put forward by Obama, even though this idea of understanding and unlocking the brain really took off publicly after 9/11, and the Brain Initiative was just a public rollout, in my opinion, for massive amounts of money to start going towards quantifying and itemizing all of the subsets of the brain, neural circuitry down to individual cells, and then down to subcellular components to understand what proteins and what enzymes and all the other things, what they do at any given time, what their unique signatures are, so that you can use those for receptor sites to, when you put stuff in the body, you can code it to look for a particular type of a protein based on the structure of the protein, so that it won't go anywhere else, or it won't bond or bind with anything else except for a particular structure, a particular protein, for example, or a particular receptor site on a cell. And so once you can manipulate memories, not only can you manipulate feelings and thought, and you basically can give somebody a completely different identity than they experience in real life. Yeah.
My thought when you came to that was that, and what if you could make everyone think that like sitcom world, where like it didn't matter what happened the previous day. Yes. You could basically everyone just goes to work, everyone does whatever, and then they go back home, and then they reset. And everyone goes back home, and then the people who are not affected by that, well, then they just benefit from the work product of a slave population.
Sounds like Groundhog Day.
That's exactly right. That's a great, concise scenario of how this technology could be
willing
used.
Willing drones.
Well, it's what we're talking about. We're all dancing around this idea of what does the automation of the human species look like? The automation of the human species.
Well,
That's really where we're going.
right. So you're talking about, okay, so there's one aspect to it. There's the automation of the human body, right? Which would be some form of merging between the brain and the body through some biomechanical joining, right? Or it could be bio to bio, but not necessarily what you were born with and developed through, right? The other one is to go the other way. The other way would be to, I think where you're headed, at least what I'm interpreting, is the aspect to do that to your brain.
If you do it to the brain, you have the body.
Right.
You actually have it transferable to anybody.
Think about it. They've already implemented this system, but we're becoming aware of it. So what they're trying to do is interrupt that. They're trying to make us basically the way we were, asleep forever.
No, understand that. I was thinking it from the aspect of automating the body.
Well, you're right, and so there are ways to do that. And right, we can look at DARPA. You can search this stuff, the haptics program and the perception program, I believe. I may be hacking that last one up, but their prosthetics research has yielded lots and lots of ways to attach to the nervous system. And when you can attach to the nerves in the body, it doesn't really matter where, other than where you attach dictates what circuitry ultimately gets stimulated through the rest of the body, be it an organ or up to the brain and subsets within the brain. So you can attach to the nerves, you can directly stimulate the peripheral nervous system, or you can go directly to the brain. So
right. The end point, right? Rather than
to your point,
they had to start with where the reaction is. They worked their way backwards and are reverse engineered to figure out how the brain is responding to that stimuli, and thus they can control the stimuli.
And so that's where I think some of the real benefits, and I'm saying that word in quotes and or sarcastically, from a kind of a sick, sadistic point of view, the benefits of war have provided ample opportunity and test cases to attach devices in various stages of development to the peripheral nervous system of amputees, people who are damaged in any way, shape, or form that you can conceive of as a result of war, to further the development of these technologies. And frankly, the technology, the value of the technologies, there's a few ways to look at that. You have the material science piece, where I like this material, it does this thing, it comes in this form factor. That's a technology, and it has an evolutionary cycle in and of itself. The real value, the real tangible value, is the software that is developed to run the computer interface piece, where they can read and understand the biological signals, understand the intent of the user, and then understand what signaling, what stimulus is necessary to achieve an intended result, like reaching out, grabbing a cup of water, pulling it back in, putting it up to your lips, tilting it so that you can drink with a prosthetic.
So it's basically no different than programming, say, a robot in a cell.
That's right. So what you get is you get a prosthetic. So you've got the robotics piece that's under development to drive the prosthetic, but then you also have the biologic piece to be able to understand efficiently what the conversion is between the biological signaling, that is the intent to perform some action, that ultimately translates to the robotic arm, and then backwards, the feedback. So what they're doing is they're, through the prosthetics program specifically, there's a few of them, they are able to understand a feedback loop that occurs with the nervous system and the brain to a prosthetic. And that's been the underpinning, if you will, for that backwards or reverse engineering piece that Pinata was saying. That was a great analogy, because the algorithms and the data sets and the neural recordings that they're getting from all this information can be normalized and then can be packaged into software to ultimately stimulate a fully functioning, a fully working person if you can override the neural impulses, if you can override the neural signaling. So once you understand what the neural signaling is, once you're able to understand exactly what that analog waveform, if you will, looks like, then you can insert it into the nervous system or the brain and get them to function.
You just made a person, a human being, an automaton.
That's what I'm saying. What is the automation of this? We're all dancing around this idea of the automation of the species, where you access the brain and you provide the brain with synthetic artificial stimulus that mimics and overrides natural occurrence, natural impulses, so that the brain and the body train and tune in to artificial stimulus that is then provided via the AI cloud. And that's
well,
where.
Yeah, well, I mean, think of the Matrix, but without the pods.
Yeah.
Without the pod stuff, it's just they don't need the pods. That's what they've already figured out. Apparently, they don't even need that. That's inefficient.
Yeah,
it's horrible to think about.
So I'm going to breeze through a few of these, and so that we don't lose the audience, if you will, just because what I just said is like, whoa, man, there's no way we're there yet. Whoa. And the answer is, well, just 10 more minutes and then reevaluate your thoughts on that. So real quick, DARPA wants to jolt the nervous system with electricity, lasers, sound waves, and magnets. Pretty self-explanatory. Biomedical program, biotechnology's office. Yesterday, DARPA, this was back in 2015. So we're 5 years in, almost to the day. October 6th this was published, 2015. And they announced 7 grants under the Electrics program. Scientists are chosen for doing fairly fundamental research. They're in the early days of electric medicine. Electric medicine. Goodness gracious. They'll investigate mechanisms by which to stimulate the nerves, map the nerve pathways that respond to that stimulation. They're working on treatments for disorders such as chronic pain, post-traumatic stress, and inflammatory bowel disease. So these are just some examples, right? So what I see in here is disorders for chronic pain. So you're literally looking at turning on and turning off nerve impulses throughout the body. Post-traumatic stress, so you're dealing with certain functions in the brain, emotional as well as visual and memory, right? Post-traumatic stress, PTSD, and inflammatory bowel disease. So it's just...
Hey, TMC,
First thing that made me think of was Neuralink, Elon Musk's Neuralink.
That's old. That's 1970s technology.
Well, what they're trying to roll out now.
Yeah, exactly.
I just did a presentation on. Mm-hmm.
Yeah, they were doing that stuff a long time ago. Were you going to say something, Spectre?
Yeah, let me ask you this. When you say DARPA, obviously it's, okay, we know it to be the research project arm, military, the government, et cetera, but obviously it comes in many different shapes, sizes, forms, and through various institutions. Candidly, we were talking before starting the recording that obviously, many folks know from following Q that DARPA, in effect, is the Facebook, is the Google side of things, and we are indeed interacting with the DARPA side of things. And if you recall, it's only been maybe, a year and a half, 2 years ago, Facebook did this little experiment on people unbeknownst to Facebook users that really jacked with the emotional side of things. They tried to elicit a response from various people by putting out some sort of, I don't remember exactly what it was, how it was gauged, some story or whatever it was, but it's kind of along the lines of what you're talking about here.
Yeah. So to your point, that's a whole other topic whereby they can understand a user feedback in a closed feedback loop. And a closed feedback loop in a simple form would be, I'm showing you video, I'm showing you a Twitter stream, I'm showing you a Facebook stream, and then I'm doing things like, where are the cameras? Here's the cameras. I'm doing things like looking at you through your camera while I'm feeding you a stream, and you get things like being able to, where is it? No, this is not the right page. Stand by. camera technology. So this patent talks about brain activity estimation using a camera. So they're looking at the space between your eyes and just above that in the center of your forehead, and they look at the blood flow there, and they can estimate your brain activity. And they did this experiment with an iPad, registered trademark of Apple, right? Image data acquisition means including a portable terminal with a built-in photographing device, such as a smartphone or a tablet. Brain activity estimation device can obtain photographed image data regardless of brightness of the external environment. So closed feedback loop means that they issue you stimulus, and the easy, most understandable way is a YouTube video, a Twitter feed, Facebook feed, anything that you're looking at with audio and video is stimuli. You're being stimulated with your phone or your TV or your computer or whatever. And with the camera, they can estimate your emotions using a camera. They can understand what the subtle changes are in your autonomic nervous system, right here. In particular embodiments, human emotions are evaluated by measuring the activities or arousal of the autonomic nervous system, where changes in arousal are indicators for various emotions. And so this results in things like a change in your pulse, and they can pixelate the main vein, so to speak, in your jugular, for example, or they can pixelate a vein that they can pick out subtle movements in your face with the blood pumping in your veins. It's actually creating an up and a down that can be looked at and viewed through the camera. And that's in the visible spectrum. They have infrared filters on these cameras at this point that are selectable. And if you have a Face ID type function on your mobile phone, for example, they've got an infrared detector that's always available on that phone. So the infrared can literally go in and monitor the blood flow. That's a whole nother piece of this, but sticking strictly with cameras, because dealing with the possibility of what if, I think a lot of people accept the fact that the camera's spying on you. So what I'm trying to illustrate for you at this point is, what does that really mean? Does it just mean that they're taking video of me? Some people may not care so much about that. But if they're able to extract things like, what am I thinking? Or what is my emotional response to looking at a blonde versus a brunette? Or looking at violence, or looking at cats, or looking at whatever, to understand what the change in my heart rate is, what the change in my pupil dilation is, what the change in the color of my skin is, indicating flushing in the skin, change in my respiration rate. All of these things put through data analytics, machine learning, is able to, at a simple sense, classify and quantify what your emotional state is and to what extent, how intensely are you feeling that emotion. Artery mapping, they can map your arteries with your camera. Facial arterial mapping is unique to each user and may serve as a facial signature that may be used as a basis to distinguish between different users. Here's other similar patents: determining cardiovascular features using camera-based sensing, determining artery locations using camera-based sensing, remote monitoring of vital signs, Oxford University, also using a camera. And they're able to take your heartbeat, your respiration. They're able to look at the saturation, oxygen saturation in your veins and your arteries. And when they do that, you have a red, green, and a blue sensor, and you have an infrared, or a red, green, and a blue feed, if you will, and an infrared feed that's ultimately your camera's picking up. So what they do is they compare and contrast red versus green, or red versus blue, or infrared versus green, blue, or red. They're using a minimum of a combination of two, and they're cross-referencing those feeds, those color feeds with the camera, and they're able to extract things like the oxygen content out of your blood, as well as looking at the pixels, and they can see the vein or they can see the artery pumping, because if you think about one pixel, the diameter or the distance of one pixel that's being read or measured in a camera, when your artery expands and contracts, it's changing which pixel is on the outside edge for that color. So you have a flesh tone, and then you have a variation in the flesh tone or a variation in the shading or whatever. And it's able to find where that movement is down to a single pixel, and they can literally track your heartbeat just by looking at the pixel variation. So, and they say here's another example there. One example of the invention, regions are used 100 by 100 pixels. So what they also say is that cameras can track different regions simultaneously. And that's pretty obvious, right? When we look at what is possible with facial recognition, being able to break down eyes versus nose versus chin, forehead, ears. Well, that's what that is that's AI and algorithms looking at different subsets of a face as a whole. And so they can track different things down to a pixel and have different categories, different sections. And it doesn't stop at your face. I mean, they can, anything that's in the view of the camera at this point, or in view of the infrared photo detector, they're able to pull information out of you. Single channel image measurement, dynamic changes in heartbeat or respiration. So this is single channel. We talked about red, green, blue, and infrared. This is saying that they can do that with only one of those channels. If you want to look more at this stuff, you can go to humaninternet.org, and this is just cameras. I'm building this out slowly, and I'm doing other things, so this kind of stalled for a minute, but there's plenty here to take up your time for months. Modifying a digital video signal to mask biological information. So this is where they take the unique biometric information and they actually put synthetic signaling over top of a camera feed to mask that from anybody else that's seeing the feed. So there are countermeasures that have been put into place for this type of biometric extraction. And what we're talking about here is a closed loop system. Biometric masking, system and method for generating an obfuscated optical signal. That's Huawei. Biometric masking from Cisco. And what we're talking about here is a closed loop system in order to understand what stimuli is being provided to a user, and then what is that stimuli doing to a user. Basic brain computer interface. It gets way more advanced than that.
Stupid question.
No such thing.
Is this technology being used to the good, or is it being used to the bad?
I'll answer your question with a question. Do you think that the intelligence drops that we're getting, do you think that is part and parcel classified as a psychological operation?
Yes.
Yes, I would say so.
Right.
It is classic. I mean, not necessarily nefarious in intent, right?
Right. But it is what it is.
Right.
So the point of that is this. I think, and by no means was it a stupid question, Inspector, I think that these technologies are the battle space, period.
Yeah. I guess where I head with that is a fundamental question, thinking constitutionally, and
we are at war. Go ahead.
Yeah, we're at war, obviously, but it boils down to, in my mind, one single question: whether or not we give consent. And there's been this notion that they have played with since the Constitution went into place, since they tore it up and put the corporate constitution in place, that everything is based on implied consent for all their legalese. And so basically what that means is, so long as you do not say no, then it is implied that they can continue to do what they're doing until people wake up, see what's going on, and say, no, we've had enough.
Here's this about that. If you are ignorant, and I don't mean stupid with ignorant, it just means you don't have the knowledge.
Lack of knowledge, right?
Yes.
Right. If you don't even know that it's happening, are you even in a position to provide an opinion on consent? And so metaphysically, I mean, what we're talking about is this metaphysical, they have to show you to some extent, but in order to
you're right. It ties into that whole,
right?
like their whole like system of like, they have to show you what they're doing in order for some sort of karmic thing on their side.
Yeah. And so I don't think that has been met. And so to your point, silence is consent. I think I'm summarizing that or paraphrasing what you were saying, Spectre. Silence being consent.
Yeah, to some degree. And I think from a showing a standpoint, dear God, I think there's been plenty of movies to show where this stuff is going. When I see this stuff come to play, just like the other night, the anons were coming up with, perhaps Biden was wearing a contact lens that had a teleprompter, had the wire, and they chased all that stuff down. I'm thinking this stuff is very Bond-esque. This is the sort of shit that Q usually comes up with the special gadgets in order to get Bond out of, dire situations, and all movies, Bond movies that I've watched. Or this is like Tony Stark type technology where, he's down in his lab and he just brings these little things up in the air and he can toggle around the 3D stuff and away you go. So to me, they've kind of already shown their hand many, many years ago where this is going, and it's just now catching up to us.
Yeah. I'll show you. I'll show you this, dude. This is what I saw. All right. So you had the RSBN thing, right?
Oh yeah.
And you had the wire thing that came out.
Yep.
And then you see this thing, you see the thing on the wrist.
Right.
That kind of went in and retract. I don't know if that's CGI or what, but I mean, there's
I was waiting to talk to you about this.
Oh, I didn't see that.
Because it looks like there's indentations on his wrist when it falls off.
Right.
And I thought it was actually the still that I saw. It looked like the top of a pin. I didn't see the motion part here.
You see it kind of like it's actually moving his forearm when it's retracting, like it's you getting that kinetic jolt there.
Correct.
So check this out. I literally, when that came through Twitter, I literally was going through a bunch of patents on my computer, and I found a patent that had a picture like this, and there's more that are like this. And what this is nanotech that's in the blood that is able to be measured and actually have stimulus applied to it in order to correct physiological information. And I'll pull this patent up for you.
So basically, he's already an automatron.
Well, he's going to have access. And in my view, when POTUS said the military is taking care of you, did you remember him saying that in the debate? He said, he actually said in the debate, and you should be so lucky, and I'm paraphrasing, that the military is taking care of you.
Oh, that's when he was talking about Bo, right?
I'm not sure.
I think that's when, I think that's when he was talking about his son.
And when I hear stuff like that, I'm
not saying that doesn't apply. I'm just saying that was the point in time, I believe.
Yeah.
When he said that.
Very good. That could very well be. To me, it's this stuff like they have some absolutely crazy technology. A collection magnet. This talks about nanotechnology literally being applied into your blood. And if they talk about measuring analytes, and analytes is just a real fancy word for specific biomarkers. It could be glucose. It could be specific other specific components in the blood, proteins, etc., in the blood. And it says here that the analyte response signal is related to the interaction of target analytes, which is just biochemicals that they can measure, with functionalized particles. That's nanotech, nanoparticles. In some examples, the system may also include magnetic particles and a magnetic field source, sufficient to distribute the magnetic particles into a spatial arrangement in the body. The analyte response signal may be differentiated from the background signal, right? It's because obviously they're creating some type of an ecosphere in their biosphere, whatever you want to call it, that they can then start making intelligible measurements of to extract information, at least in part based on the modulation of signals, and due at least in part spatial arrangement of magnetic particles. And so what they're talking about is inserting magnetic particles in the blood and being able to have those interact with the bloodstream, and it measures and can correct behavioral, physiological information. And so it says here, for example, glucose meter, test and measure various analyte levels, other parameters in the blood. Blood tests are infrequent. And so this thing is something that interacts with the body in real time, 24/7. It's basically non-invasive once the nanotech is in there. Again, it's kind of outside of the scope of what we were talking about, but to that point, you get this DARPA next generation non-surgical neurotechnology. And before we go there, where I was at was this page. DARPA wants brain interfaces for able-bodied warfighters. It says here, the N3 program will create no surgery required neurotech, brain tech, that the general public may also find useful. And so there's a whole article here. You can just search DARPA N3 and you'll find all of this stuff. And here's an illustration that looks at the old way and the new way. The old way is a spike or a probe that goes into the brain, an ECOG array, and that's been referenced a lot, and it's considered very, very standard. So the ECOG array looks like this, and this is your standard ECOG array. You want to look up number 2663. They talk about the ECOG array in there and how this is just this is old school right here, and this is technically a Utah array, but it's ECOG. It's ECOG. They're one and the same. It just depends. They have different kinds. They have these that implant, literally like press into the tissue, and they have some that overlay. It's like a silicon pad, and I'm using this just for descriptive purposes. It's like a silicon pad that's got little circular electrodes on it that overlay on top of the brain, and that's kind of similar to what you see, similar to something like this, where it would be they would open up the skull and they would insert this thing and it would unfurl and it would just lay on top of the outside of the brain, in between the skull and the brain, versus the ECOG array or the Utah array that they cut your head open and they attach this thing in there, and then you get a little box on your head. You see this box right here on this patient's head? There's two of them. She's got two of those Utah arrays in her head in order to control prosthetics and to be able to run and interact with computers like a mouse on a computer screen. And this is old. This is very, very old technology. But what the benefit, the real value of this is not the hardware. Oh, wow, look, we can cut somebody's head open and put something in the skull or underneath the skull, and then we can attach a box to it and they can do things. No. It's the software, it's the data set, it's the algorithms that are used to run and drive this stuff, because those algorithms and software have to be able to encode and decode information into and out of the brain. And so the value is in the software. And once you have the software, it can then be deployed through the cloud. Here's another one. This is a video where Obama actually shook this prosthetic hand, and this guy who's completely paralyzed was able to feel the pressure of Obama's hand being or squeezing the prosthetic arm. So he was able to move the arm and engage using the prosthetic arm and shake the former president's hand. And when that handshake occurred, there are sensors on that prosthetic hand that then sent signaling back into his brain. So he literally feels pressure sensation as if his hand was actually being grasped and shook, because it's tied into that part of his brain. And this is old technology. You can see the boxes on his head here. Well, they've moved.
Do you know how long that video is, TMC, that you're showing right there?
I don't know if I click the boxes.
Because I know it's NBC. I'm just trying to think, can we play it?
It's a minute and a half.
And if no,
we can play it without sound.
Pause it.
We should be okay.
Yeah. I would love to.
You can't hear that sound, can you?
Good.
No.
So he gave him a fist bump, and they're interacting. He's doing all this with Obama. Watch Obama's first bump and robotic arm powered by a brain chip. It looks like it's just buffering and stopping, whatever.
Yeah, and if there's any links you want to provide me that you want me to put down in the bottom, if you just want to send them my way, I'll be glad to do that.
When I drop share,
especially for your website too, please.
I'll blast them out to you. It's funny, it stopped on 17. I'm just saying. Anyway, it's the weird. Anyway,
that is unusual.
We all look for that. So it's like when you get a new car or a new color car, all of a sudden that's what you see on the road all day, right?
Right.
I'm sure everybody has that experience. So nah, can't be. So DARPA's N3 program. Oh, we digressed here real quick. So the old way was the pins in the matter, in the flesh, right, or in the brain tissue, if you will. And what you see here is skin. You see the different layers, and you get ultimately down to the brain, right? And so what they're getting at here is you're going from pins. Instead of that, you're using sound and light. Those are pressure waves. Those circle, the ones in purple, are pressure waves, and this is infrared light. And so with the two of those, they can actually target down to 1 voxel, which is basically 1 cubic millimeter. That's the minimum standard they're looking for. Obviously, they want down to single neuron resolution, but the minimum standard that DARPA put out is 1 cubic millimeter to be able to stimulate the cells, the neurons, in 1 cubic millimeter with some type of a peripheral field stimulus, whether it be a magnetic field, electric field, focused ultrasound, or focused infrared light. And infrared light goes approximately 10 centimeters into and through the body. Infrared light passes through the skull, no problem. And they have algorithms and machine learning that is able to understand how the light diffuses through tissue, through the bone, into the brain, and they can reconstruct it, meaning that they can transmit the light knowing how it's going to scatter as it gets to the intended location, and they transmit it basically in a scattered form, reverse creation, reverse engineering it, so that they know exactly what the focused beam is going to be when it diffuses through the body and the skull and skin, skull, etc., to get to the brain. And they can do that. And they talk about that. Regina Dugan talks about it with her Facebook discussion. And a lady by the name of Mary Lou Jepson talks about it. She's part of the Open Water program. And the Open Water was listed up here as one of the main companies that are working on a brain-computer interface. And search Open Water or search Mary Lou Jepson, and you will see her talks about infrared light and what they're doing with brain-computer interfaces that are non-invasive. Something like a ski cap is going to allow complete and total telepathy.
And you know how you just said that when you get a new car, you see the same one every time you see water, you think, watch the water.
Yeah.
You know, it's crazy. This is really interesting, by the way. And I agree with you. If you think things aren't possible, just look for the patents, if they exist, and the technology does to me.
I've spent 3 years looking at this stuff now. So it's, I am convinced. Completely convinced. And it's not just, let me go look at the latest and greatest targeted individual video where somebody's put out all these cool graphics with signal analysis graphics and people that say that they this, that. Okay, fine. That's all I see out there as it relates to this remote interface, remote manipulation technology. And I'm like, you know what? That's not enough. So I've spent the last 3 years physically, tangibly looking for things that are legit. It's legit. Before we go through N3 to that point, I'll show you this. This is a workbook that I have, and this is just a tab on cerebral programming. And these are all patents for manipulating and interfacing with the brain to create permanent, lasting change or effect. A method of inducing mental, emotional, and physical states of consciousness, including specific mental activity in human beings. Computational system and method for memory modification. Method and apparatus for changing brainwave frequency. Cognitive enhancement using feedback. This one's real interesting. It's got a little yellow highlight here. Aggregation of biosignals from multiple individuals to achieve a collective outcome. This is something that NASA was working on, whereby they hook up like 3, 4, 5, 6 people together. They put brain arrays on them, like wearable brain tech, EEG monitors, and they collectively work through solutions. And what that patent talks about is being able to reach collective outcomes more efficiently, more effectively, more accurately than if one person was dealing with it. That
sounds like the movie Inception.
That's the hive mind. That's the Borg right there.
Yeah. Well, there's a patent for that.
So here, if I may, TMC, in this particular case, maybe you should not go into it, all of these guys, but whether you use one as an example or not, what it takes to get a patent, because there are patents for many different things. It's an aspect of the theoretical versus the applicable, and when do they get the patent? Because to understand. Maybe the way I pose it as a question is just to show how much effort they actually have to demonstrate to the patent office to be able to obtain the patent. It's not just saying something like, hey, patent office, I got this idea. Cool. Here's your patent number. Click.
Yeah, there
right?
has to, you can patent an idea, but there has to be enough tangibility there to pass the red face test, so to speak. So realistically, it's going to require, if it's just an idea, right, it's going to require peer review. It's going to require some type of a prototype working model. And not every idea is physical, right? There's lots of patents for algorithms and software and what you would consider virtual conceptual property. So it doesn't have to be like, it doesn't have to be something physical that you've built with your hands, so to speak. It literally can be intellectual property that's patented, but it has to have validity. It has to have extensive citations and potentially peer review. And the patent office has criteria by which things will be qualified or disqualified for patentability. And so there is a process for that. Now, to that point, I have seen patents that are they're jokes, and yet they're still patents. And the criteria, it's not criteria. The content is the word I'm looking for. Is very lacking in those patents, and they're interesting to read. And there are on occasions times when I've looked at what they call the patent citations out of those patents to find other patents, but those are not any that I really provide. I don't rest my hat on them, so to speak. So patent citations, you have non-patent citations and you have cited by. If you ever want to go down a rabbit trail, just start looking at, pick a patent and go down to patent citations and cited by, and you will see, all of these are different patents, and what these are citations that reference similar concepts, and or they're actually cited. They're actually cited in the actual patent that you're looking at. So this one has patent citations that crowd-based scores for food, from measurement for effective response, wearable electromyogram sensor, that's measuring the muscles, Korea Institute of Science. So it's
yeah, and the main reason I asked that is not to necessarily detail out the process and all. It was more or less to show that the list that you have compiled has a good amount of validity, in that the amount of effort that it takes to get a patent. Yeah. And what you found are the items that have had that somewhat rigorous effort, not just your brain fart, right? Yeah. And that's why I'm saying, to put the value on it, that what you're showing has actual tangible value, that people are actually investing a lot of time and money and are locking and loading, because the reason you get a patent is to control ownership of that.
Right. It's one of the things that, it's private property at that point. It becomes private property. So this one, for example, was assigned to NASA, and it shows abandoned. And I used to shy away from abandoned patents, but I don't anymore, because what I'm finding is when I look at a family of patents or something in the same vein, I will learn, just as if you learn through reading a textbook, you will, if you read enough of these things in the same family, if you will learn a lot about biology, you'll learn a lot about the technology, you'll learn terminology, and then what you'll find is publicly available white papers online that back up and support what it is that's patented. And so at that point, it becomes what's conceptually possible, and what are these people, when I say these people, I'm talking academics and commercial R&D groups, what are they actually working on? Where are they spending their money and their time? And my interest at this point is brain-computer interface. This one down here is literally funded by DARPA. This one down here also is literally funded by DARPA. Targeted steerable transcranial intervention to accelerate memory consolidation. method for low latency automated closed loop synchronization of neurostimulation interventions to neurophysiological activity, blah, 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 blah. What's that? Automated closed loop synchronization. And that's really the coup de grace, is a closed loop whereby you're able to create a system that is able to stimulate and read what's going on in the brain. So I can stimulate the brain and then I can read what that stimulus is doing, or I can read the brain in order to understand what the appropriate stimulus that is needed to be provided to the brain to achieve an intended outcome. And the military is looking at this so that soldiers can ultimately interface with computer systems and AI. And that's kind of what you see the overlay here. So you remember in this other document, I think it was here. Where'd it go? I just killed it. That's not good. Hang on. Let me bring it back to life. This one right here. What we saw here was the new way of interface was with sound and light. These are just two examples. There are other ways to do it. You have the sound and light. And so in this example right here, this is exactly what they're doing. There's a helmet-based system, and they've cut it away, or they've made it translucent, and they're showing that you're going to have transducers that are going to generate sound and or light or other things and create focal points in the brain that are ultimately going to allow an interaction or an interactivity between computers and the human. And this is ongoing. This project has been ongoing for a number of years. And so you've got sensors and stimulators here that are outside, and then you've got nano transducers, injectable, ingestible, intranasal, which means they can be inhaled. So you can drink or eat them, you can inhale them, or they can be injected. So what does that cover? Food, water, air, and vaccinations. Nanotechnology, membrane modifications, molecular assembly. This is where we get into that biotechnology, DNA, RNA, and what they can do with doping nanotechnology. And I can show you some of that at some point, whereby they can take this nanotech and they can attach DNA or RNA to it, and so that it will go in and it will find a particular receptor site or a particular cell, and it will have the right lock and key configuration, and that's where that nanotech will go. Furthermore, what they can do is they can assemble this nanotech so that it creates structures, lattice structures, complex geometrical shapes, because they're able to understand and design DNA, strings of DNA that fold, what they call DNA folding or DNA origami. And they can predict and understand with great specificity at this point how DNA is going to manipulate itself once it undergoes the right reaction. The reaction can be energetic. It can be done with a change in pH. It can be done with a change in enzyme. It can be done with a particular additional piece of genetic code that attaches to it. And ultimately what we're talking about are remote or delayed triggering mechanisms. So the DNA can be attached to nanotech, for example, or just be DNA in and of itself introduced into the body. And then at a later time, a triggering event occurs that makes that genetic code do something. And yeah, this is where we're going with all of this. And so what you see here, phase 3, right, is this idea of a bidirectional system to achieve low latency, decode motor and cognitive skills, and encode sensory feedback. Decoding and encoding all 5 senses into and out of the brain so that you get sensory feedback when you're remotely piloting a drone. This is DARPA, what they're looking at doing. Non-invasive metrics, 1 millimeter cube spatial resolution. These are the requirements, phase 1, 1 millimeter cube spatial resolution. Time, temporal resolution, less than 10 milliseconds. Your heart, for it to go through its electrocardiogram cycle, is 250 milliseconds. For the bloop, bloop. For that spike and fall and normal, it's 250 milliseconds for that to happen. They want time resolution down to less than 10 milliseconds so that it is a real-time, fully immersive system. There is no delay. It functions as fast or faster as your impulses do. Stability, continuous operation for greater than or equal to 2 hours. Well, we got to make sure that everybody gets their 2 hour, 4 hour, 6 hour break now, don't we? Accuracy, read, write, greater than or equal to a 95% read or write capability. Channels, minimum in phase 2. The amount of channels, they're calling these channels in your brain, 1 cubic millimeter sections of your brain is a channel, greater than or equal to 16 channels in your brain, minimum, totaling 16 cubic millimeter of stimuli. So you can imagine if they were to selectively apply or selectively encode 16 cubic millimeters in your brain, not all in one spot, some in your vision center, some in your motor cortex center, some in your audio center, some in your memory center, some in your emotional center. Maybe they don't want you to get afraid and pee-pee yourself when you're looking at the enemy in the eye, right? Now, when they have all 16 of these or more structured in your brain, now they can start creating circuits in between them. And now we're talking about potentially being able to wire or rewire the brain beyond just interfacing with robots, interfacing with drones, interfacing with computers. Because once you get to this point, now you can start sending stimulus into the brain to remotely target and remotely fire specific regions of the brain in specific succession, right? Where you're creating a recipe in there, if you will. It's like playing an orchestra, only the orchestra is the neural firing in your brain. At what point do you lose free will? I just want to throw that out there. At what point do you lose free will? We'll go deeper down this rabbit hole in a minute here. Minutely invasive metrics versus non-invasive. Non-invasive is I put on a helmet and that helmet can do something to my brain. Minutely non-invasive means something that's injectable that will ultimately deposit somewhere in the nervous system or the brain, or will ultimately genetically modify the brain so that the helmet will interface more effectively. And I'll show you both of those options here very shortly. Integrated device, you have nanotransducers, right? Transduce neural activity into sensors, transduce stimulation modality into neural activity, reading and writing with nanotech. And then you have, obviously, they're going to want it to be, for the military, they're going to want it to be encrypted. So you're going to have systems that are specific to the military that are going to be their own network, their own architecture. But once they do that, the template is made, the platform by which this technology can explode and manifest in all forms in our society, it will be made. It will be there and it will be available. And so going back to Neuralink, this is where DARPA's at now, and they're already far along. There's patents for this stuff already. So this idea of cutting open a little circle in your head and inserting a quarter-sized or a dime-sized disc in your head that's going to have little micro wires poked into your brain, dude, that is like 1970s technology. There's no reason for that. Not when they can give you a shot and put you in a magnetic field and steer this stuff up through to your blood-brain barrier. And then the nanotech that they injected into your blood has liposome or glucose or a specific type of protein that the nanotech is hiding inside. So they encapsulate it with something that's bioavailable that the body or the brain thinks it needs. And that is the gatekeeper or the token to get past the gatekeeper. So they dope the nanotech with whatever they want, and then they encapsulate it in something that the brain thinks is safe and that the brain thinks it wants, and it passes the blood-brain barrier, and then the nanotech is able to do what it wants after it passes through the blood-brain barrier. That's just one way to get it past the blood-brain barrier. There are other ways to do it. They have sonoporation, where they use ultrasound that literally vibrates the membranes, vibrates the blood-brain barrier open so that all media can pass through up to a certain size. Sonoporation using sound, and they have electroporation where they use electric fields or electromagnetic energy, and they can electroporate cells as well to pass nanotech or whatever they want into and pass through the blood-brain barrier. But a more sophisticated way of doing that is to dope it with biologic material like fats, lipids, for example, that the brain thinks it needs. And the nanotech is inside an encapsulation of lipids that are then viewed by the blood-brain barrier as safe, and it passes right through. And so this is a ongoing project. Let's move on. Patel, one of the winners for the DARPA N3 program, develop injectable bidirectional brain-computer interface. And I'll show you this diagram right here. It's real pretty.
It's something that came to mind, if I may ask.
Yeah, please. It's a good time.
Could, aside from the vax and the excuse of COVID for the injectionable materials, right? Mm-hmm. Whichever technology is available, let's say, could the virus itself be the receptor, be the aspects of the component necessary in the body for what they're going to? I mean, when you think about the virus and the traditional vaccines and so forth, right? Yeah. They don't necessarily attack the virus. They stimulate the antibody process in your system to create your own body to reject the virus, to attack it if it invades. Well, could the virus itself then be used as the base blueprint, the foundation?
Yes.
Right?
Yeah. Well, think of it as the, a signature. Once they have the signature, then they can overlay compatible programming on top of it.
Right, understand. So I was thinking that from the RNA vaccine perspective, but kind of in reverse. If the COVID-19 has been genetically engineered, then would it not go that genetic engineering could be the receiving basis that automatically spreads to the populace, that when you actually give the vaccine or an injectionable item or consumable item, because a vaccine injectionable is consumable, then acts to supplement the virus, not to kill it.
Yeah, so we're dancing around this idea of a viral vector gene delivery. That's what a virus does.
Exactly. And that's
open air.
Right, because that's what the RNA vaccine comes in, right? Not to digress into that, but
no, it's fine. And we were going to go there. We'll go there first, and then we'll go back to the magnetic nanoparticles as delivery vehicles for genetic information. That's another way to deliver genetic information, genetic payloads, is using magnetic nanoparticles to then ultimately put the body into a magnetic field. Those magnetic nanoparticles respond to the magnetic field, and they can steer the nanomagnetic material to where they want it to go and then deliver genetic payloads. The other way to do it is with viral vector delivery, and that's what this article talks about. And to your point, there's two ways to look at it. You could have the COVID open air pollination, if you will, open air vaccination. If you look up Bill Gates, he's been interested in open air vaccinating programs forever, right? Yeah. So you can genetically engineer whatever you want at this point, basically. You can genetically engineer a virus that then, when it goes into the body, becomes either something that permanently changes different pieces of the body, or, as Pinata was saying, I think you were getting at, becomes a one part of a multi-part system. So you can have a binary, tertiary, quaternary system whereby over the course of 2 or 3 years, you introduce genetic information that will, quote unquote, self-assemble upon activation. So you could have coronavirus, for example, and I'm just using it because that's just a word that we all know at this point. You could have something like a coronavirus that's been genetically manipulated go into the body, and it sits there dormant. It goes through, you get infected, you develop antibodies or whatever, but that genetic code now is there. It's there. It's sitting there.
Right.
Then you administer a vaccine, or you administer next year's virus that's going to go pandemic or go global. What doesn't matter. I mean, they've been manipulating viruses forever under the guise of fighting against, biological warfare. Yeah, SARS,
fighting against the virus.
All of it, dude.
Right.
Yeah. So it's not inconceivable to think that you could have an open air contamination program that is less effective than a vaccine because it needs to be more stable. It has to survive in an atmosphere rather than in a vial or a shot or syringe to then be delivered into the body. So there are some drawbacks to that. There are strengths and benefits to those different delivery mechanisms. With the vaccine, you have much more controlled environment so that you can have a more complex, sophisticated system. And in an open air pollination, open air contamination type environment, the virus itself needs to be more stable so it lives long enough to go ahead and infect everybody. So you're not going to have the same benefits that you would, or the same attributes.
TMC, I wonder if maybe you're getting at that if you could create something that's like a super strain, but then like with all those pieces is so concentrated, they would basically have to do an injection. But an alternative would be to create separate strands and then basically let it go all over the whole world once, twice, thrice, or 4 times over, right? And then assemble itself naturally over the course of time, as opposed to like, because a lot of, we all know the rejection that would be if there were mandatory vaccines, but if they were to just basically go through and assemble all of their pieces somewhat, and I'm using heavy quotations there, naturally, then they would be able to do that. Is that kind of what you're getting at?
Yes. And so that's, I think, looking at the whole COVID thing and the mobilization and this idea, especially in the United States, of getting corporations to tool up to respond to pandemics, social distancing, deploying these testing platforms, going through all of this, engaging the military, developing procedures that are tangible, that have a greater likelihood of success in the event of a real pandemic through this fake one, right? I think that's a silver lining to all of this, is because if biological warfare is going to continue, and it will, because we are a globalized planet now, when these things come up, you are going to have the pharmaceutical companies and or research facilities, military and otherwise, academic, military and commercial, spun up. They're tooled up. They've gone through this exercise for, it's going to be a year or more, to be able to respond quickly. And that goes in line for manufacturing. It goes in line for disaster response. It goes in line for first responders. It goes in line for hospital procedures, work procedures, down to the individual citizen procedures as it relates to understanding what the importance is of cleanliness and hygiene and distancing and isolation and perhaps even preparation, so that if something had a kill rate of 2%, people would be freaking out. This thing has a kill rate of nothing. Very, very few are at risk of death of COVID-19, unless you have underlying conditions or are incredibly old.
Right.
Those risks exist with any cold and flu virus. That is no different. In fact, this is showing to be less lethal than previous years of flu, which makes you wonder if those have been weaponized. And it makes you wonder, again, how far along this genetic manipulation we really are, if, in fact, they have publicized this one, to your point, Pinata, earlier about inducing fear and having that ultimately be like this stimulation, if you will, to society to ultimately try to inject or insert control, permanent lockdowns, totalitarian technique type control. What if this isn't the first time that genetically modified organisms have been released to infect the general population for some long-term binary, tertiary, quaternary program? I'm not saying that's happening, but what I'm saying is because of the publicity of this one, it makes one consider the possibility of what if. And to that point, this program right here, Moana, it's from Rice University, also another winner of this DARPA N3 program. They're looking at building a helmet that, I'll say it right here, right? In 4 years, we hope to demonstrate a direct brain-to-brain communication at the speed of thought without brain surgery. $18 million project, DARPA N3 program. Sharing visual images between two brains may sound like science fiction, but Robinson, one of the people at Rice, and said a number of recent technological breakthroughs make the idea feasible. Just how feasible is the question DARPA hopes to address with the N3 series. Rice University led team and 5 others have proposed different technological solutions for a broader challenge of connecting brains and machines. Speed is the key. Electrical and computer engineer said, bioengineering, right? Rice University's Brown School of Engineering. We have to decode neural activity in one person's visual cortex and recreate it in another person's mind in less than 1/20th of a second. 1/20th of a second. The technology to do that without surgery doesn't yet exist. That's what they're going to create. So what they're looking at is a Moana helmet, right? This helmet, Rice's magnetic, optical, and acoustic neural access device, or Moana, will test techniques that employ all three. So this is a testing apparatus. It's going to look at using magnetic, optical, or acoustic. This is all wireless energy, because humans aren't going to want to walk around with a power cord plugged in their ass or a LAN cable plugged into the back of their neck. It's got to be wireless. So this is the first step, something right alongside the head. First step to something that is completely open air. You walk around, and if you're nearby a wireless access point, a television, a cell phone, then the signal to noise ratio algorithms will get better and better and better, so that instead of wearing a helmet, you won't have to wear a helmet anymore. It'll just be you being you, and everything about you is going to be known. Every single impulse will be known. Stimuli could be applied to you. I'm not saying it's happening now. What I'm saying is this is the trajectory or the trend that this is going, using magnetic fields, optical fields, or acoustic fields. Now, how many of those energy sources are emitted out of a cell phone? Exactly right. TV, same thing. Computer, same thing. When you look at a smart connected home, it's the same thing. Refrigerator, stove, oven, thermostat, alarm system, cameras, phones, Wi-Fi, television, computers, lights, your lights. All of these things are going to be connected.
Just because I happen to be in my kitchen, as most of you know. So for instance, like refrigerators, what kind of sensors do they have that you're talking about?
So a smart refrigerator of tomorrow, right, will have a camera that looks inward and outward.
Yep.
And the camera
they already have it work. They already do the inward.
Please.
No, they already do the inward.
And what does it do?
Well, that's where they look inside, and the one where you can actually have the LCD screen that actually reads what you need.
That's right.
Then if it's connected, it can actually send a shopping list to the store.
That's right. And how would it be connected to your home network?
Oh, wirelessly, of course.
Very, very good.
If not through the electrical power grid inside your house.
But the other IoT stuff, I mean, that's not necessarily something you would connect to the network, but may automatically connect to nearby networks. Is that something that's available that they do?
You mean like set up connections, whether or not you have any knowledge of it or desire? Right.
Or like just the appliance itself. It just sits there. You didn't do anything to it. It doesn't have the capability to do, well, it's not like a smart screen or whatever, which it's an appliance. It doesn't matter what it is, but it knows that there's the closest Wi-Fi source and just connects to it anyway.
Yes.
Yeah. An unsolicited connection. Right.
Yes. And that's
exactly.
And they do. And if you don't think they do, okay, fine. You can believe that, but they do. And if your fridge, for example, since we're talking about a refrigerator, if it's not Wi-Fi connected, that doesn't mean that it doesn't talk. Because just as Tien said, you have data over power line communication. And if you don't think that because it doesn't have Wi-Fi or a camera or any of those things, it can't hurt me, that's also not true. Because that refrigerator draws a lot of power. And so
that's kind of what I was after. Like, so that's what I wanted you to kind of expand upon. Not necessarily like drawn out, just what you're talking about. It doesn't matter the level of appliance that you have. They can still get information from that appliance, whatever it is.
Yep.
They can, and the refrigerator will emit a particular amount of electrical energy. It will create its own electrical field. Like when you stand in front of an electric stove, you are in a very strong electric field. Same thing if you're standing next to your dishwasher when it's running, or your refrigerator. Those things emit electric fields based on the amount of power that they draw. A hairdryer, for example, also emits a huge electric field. Those things can be modulated. Those things can be manipulated, especially things that are on all the time, like a refrigerator. And so this whole idea of having a smart meter on your house basically means that they've hooked up a computer to your power supply to your house. And there are patents that discuss, I'll show you, there are patents that discuss being able to do things over power lines. Apparatus to affect brainwave entrainment over premise power line wiring. This patent talks about generating artificial circadian rhythms using a basic frequency exclusive XOR circuit to modulate very high frequency carrier waves over premises power line alternating current. And so what this thing does is it's able to take and segment the power circuits in your house, and it's able to modulate and oscillate the power very gently, but enough for your body to interact with it. And it does it in a way to circumvent the body's defense mechanisms for basically being in an electromagnetic field. Your body has a natural resistance to those things, but they've studied that, and what they can do now is they can create artificial nighttime, a circadian rhythm cycle of night in your house during the day, and vice versa. And that's what this patent literally talks about. And there's another one. Sensing user input using the body as an antenna. This is Microsoft. And what this patent does is it talks about linking a smart device to your power grid, to your home power grid, and it's able to understand gesture recognition and whatnot using the electromagnetic fields that emanate from the power lines in your walls. And what that means is that the power lines in your walls, they emit an electromagnetic field, and your body interacts with that field and changes the field characteristics. Well, with the smart meter, for example, that thing's connected. It's got a computer associated with it. And in this patent from Microsoft, it talks about being able to use a phone, right, to act as an interface to be able to read the changes that are being made as you move throughout these electric fields, these electromagnetic fields that your home power lines emit. And it talks about appliances and other things in here that generate these fields. And as you move around through the fields, they talk about using those movements, arm gesture, waves, etc., to do things like control the volume on your stereo or your television or whatever.
TMC, we've had a conversation before I think is very relevant here that will help people understand the kind of thing you're talking about. We once had a conversation, this was not even a year ago at this point. I was asking about Wi-Fi and how just a generic Wi-Fi router works in a home. Mm-hmm. And I had no idea that this is what was happening. You were saying that, the actual Wi-Fi or the router, whatever's generating the Wi-Fi source, is actually directional antennas that can actually track where the devices are. Thus, they kind of have almost a digital picture of what is going on, tracking movement.
So there's a whole.
Can you kind of explain
section.
A little bit about
Sure.
why, or that's kind of what you're talking about here, right?
Yeah, the power line piece, the power lines, that's just one field. The Wi-Fi is much more sophisticated, but I think they've had this power line technology. And when you think about the NSA and national security and people, like being able to log into somebody's house and understand where they are and what they're doing with signals intelligence, I got a feeling that they've been able to do that for a long time. But that being said, on Wi-Fi, they can understand everything about you with Wi-Fi. Like for example, let me drop share it and reshare it real quick so that we get sound, because this is important. Just to give you an example, they can
right.
do.
I didn't mean to redirect. I just meant. I think that's a good example for the layman coming in to understand, because that blew my mind. It really did. It was really good example.
I'll show you the emotional recognition with Wi-Fi, and then to your statements as it relates to targeted beams. It's called beamforming. I can show you a video on that's also pretty good. So this one.
This video describes EQ radio, a new technology from Professor Kitabi's group at MIT that can recognize people's emotions using wireless signals. Was there a moment in your life when you looked at someone's face, but you could not figure out how they feel? What if your wireless router can tell people's emotions even if they don't show them on their faces? This is exactly what our technology does. This is our device.
So we're going to pause just to make sure we keep it clean. So this is the device right here. But again, this is an MIT, this is a lab experiment, right? These are horn antennas, and it's very, very precise. And what this does is the more bulky and regimented the hardware is, the simpler the algorithms can be to get the intended result. Once they've established that something is possible, then it becomes improvement of the software so that it can be rolled out on something like, what you have powering your mobile connection that you're likely listening to this on right now.
The device transmits a wireless signal which reflects off a person's body and comes back. It captures these reflections and analyzes them to infer the person's emotions. Specifically, our algorithms zoom in on the wireless reflections to extract the minute variations due to breathing and heartbeats. We then further analyze these reflections to extract the breathing signal and the heartbeat signal. We then zoom in more on these signals to obtain individual heartbeats and breathing cycles, and feed these as features into a machine learning algorithm to recognize a person's emotions. The device.
Machine learning algorithms looking at the wireless signal reflections that are bouncing off your chest and your face and everything else, and then being fed into machine learning algorithms to understand what your emotional state is using your Wi-Fi.
The device can automatically know if the person is excited, angry, sad, or happy. Our device can recognize emotions with an accuracy of 87% while relying purely on wireless signals.
All right, we're going to stop and we'll pick this up on Friday. I think it's going to be 2 a.m. Eastern Standard Time. And we'll back it up a little bit. We have approximately an hour and a half left. So we'll back it up just a touch and we'll finish this at another time.